There is a common explanation for the Heisenberg uncertainty principle that sounds satisfying and is almost entirely wrong. It goes like this: to measure where an electron is, you have to bounce a photon off it. But a photon carries momentum. When it hits the electron, it kicks it. So you disturb the electron by measuring it. That is why position and momentum cannot both be known precisely. This is called the observer effect. It is real. But it is not what the uncertainty principle says. The actual principle is stranger. It says that an electron, before any measurement, before any photon, before any disturbance, does not have a simultaneously definite position and definite momentum. Not because we do not know. Not because our instruments are crude. Because definite position and definite momentum at the same time is not a property electrons have. It is not even a well-formed question, the way asking what is north of the North Pole is not a well-formed question. Here is the physics. In quantum mechanics, the state of a particle is described by a wave function, a spread-out mathematical object that encodes probabilities. If the wave function is very narrow, tightly localized in one place, you can say with precision where the particle is. But a narrow spike in space, when you analyze its frequency content, contains many, many different frequencies. And in quantum mechanics, momentum is determined by frequency. Many frequencies means a large spread in momentum. You cannot have a narrow spike that is also a single pure frequency. The trade-off is exactly like music. Play one sustained note on a piano. It has a precise pitch, one frequency. But it occupies all of time, from when the key was struck to whenever you release it. Now consider a single instantaneous click. It has a precise moment in time. But analyze its frequency content, and it contains everything, high, low, every pitch at once. A sharp moment in time spreads across all frequencies. A pure frequency spreads across all time. You cannot have both. In quantum mechanics, position is like time and momentum is like frequency. The analogy is not a metaphor. It is the mathematics. The practical consequences are enormous. Without the uncertainty principle, electrons would spiral into the nucleus and every atom in the universe would collapse in about 10 picoseconds. They do not collapse because localizing the electron near the nucleus would give it enormous uncertainty in momentum, which means enormous kinetic energy, which pushes it outward. The uncertainty principle is, literally, why stable matter exists. Your chair, your hands, the atoms in your brain, they exist because of this. Heisenberg wrote the inequality as delta x times delta p greater than or equal to Planck's constant divided by 2. You can make position as precise as you like, but momentum blurs. You can make momentum precise, but position blurs. You can find a compromise. But you cannot eliminate the trade-off. It is not in the instruments. It is not in the observer. It is in the structure of the universe, written in units of the smallest action there is. Below that line, questions stop having answers.